મિત્રો in haloalkanes and haloarenes last time we can discuss about the preparation methods of haloalkanes and haloarenes. Now in haloalkanes and haloarene we can start the new point, which is physical properties of haloalkanes and haloarenes. Clear? Now we can start the new point, physical properties. If you can think about the state and color, of haloalkanes and haloarenes, then alkyl halides are generally colorless when pure, but bromides and iodides develop color when exposed to air. Means all alkyl halides are colorless when it is in a pure state, but if bromides and iodides are exposed to air, it can develop the colors. Clear? And second point, many volatile halogen compounds have a sweet smell, pleasant smell or sweet smell. Clear? So many organic compounds are there which contain a halogen or volatile. It is a sweet smell compound. Clear? Like CCl4, chloroform or whatever. So it is the first point which we can discuss about physical properties, first state and color. Alkyl halides are generally colorless when pure, but bromide and iodides develop color when exposed to air. Yes. And next point is many volatile halogen compounds have sweet smell. Clear? So it is the first point. Now we can think about second point and very important point, melting and boiling point. Melting and boiling point. In this point we can discuss about the state also. First of all, methyl chloride, ethyl chloride and methyl bromide and some chlorofluorocarbons and some chlorofluorocarbons are in gaseous state at room temperature. That is the main point. Clear? Methyl chloride, ethyl chloride, methyl bromide and some carbons or methanes, one carbon containing. Chlorofluorocarbons क्यों तो अपन कोई फर्क ना पड़े, but we can specify it are gaseous state at a room temperature. Higher ones are liquids and solids. Now we can think about the melting point and boiling point. Clear? Halogen containing organic molecules are generally polar. Yes. Now we can discuss why organic molecule containing halogen is a polar. First of all, we can say that there is a bond, CX bond is present here. Carbon is partially positively charged, halogen partially negatively charged. Therefore, it is a polar compound. If halogen is present on an organic molecule like carbon, it can have at least one CX bond, and the polarity is developed like that. Now, we can think about the boiling point of parent hydrocarbon or comparable molecular weight hydrocarbon and alkyl halide, then the boiling point of alkyl halide is higher. Yes, first of all we can remember it, then we can discuss the theory why these occur. આપણે એવી વાત કરી કે સપોઝ કે મારી અગર CH4 મિથેન है and we can replace the hydrogen and we can generate CH3X whatever. It is a parent hydrocarbon from which we can synthesize the haloalkanes. So if you can compare the boiling point of these two, then the boiling point of Rx is higher than this parent hydrocarbon. Or if we can have comparable molecular weight hydrocarbon, means molecular weight of hydrocarbon and alkyl halides are near about, and we can compare the boiling points, then also boiling points of alkyl halide is higher. Why? We can explain it or we can understand it. Concept clear? Parent hydrocarbons થી પણ alkyl halide નું boiling points વધારે હશે અને comparable molecular weight ધરાવતા હાઇડ્રોકાર્બન થી પણ Rx નું molecular weight વધારે હશે, જ્યાં X is equal to ClBrI, not fluorine, ClBrI. આને નોટ કરજો, fluoride નહીં, ClBrI, where X is equal to ClBrI. Now the reason is that due to higher polarity in Rx, boiling point of Rx is higher than parent hydrocarbon or comparable molecular weight hydrocarbons. Any doubt? Because if we can have a hydrocarbon, there is no polarity. But if we can have, this is two reasons here. First is polarity. Due to the polarity, intermolecular attraction forces increases. Which is dipole-dipole or van der Waals attraction forces. Clear? If two dipoles are generated, partially positive and partially negative, second molecule have also a dipole, partially positive and partially negative. There are interact by dipole-dipole interaction or van der Waals interaction forces. Therefore, if polarity is there, then intermolecular attraction forces increases. If intermolecular attraction forces increases, then boiling point increases. And this type of phenomena is not occurs in hydrocarbon because hydrocarbons are not a polar. હાઇડ્રોકાર્બન ની અંદર આવી રીતના પાર્શિયલી પોઝિટિવ ચાર્જ ને નેગેટિવ ચાર્જ જનરેટ થતા નથી, મીન્સ એની અંદર પોલારિટી નથી એટલે એની અંદર ડાયપોલ ને વાન ડર વાલ્સ ઇન્ટરેક્શન ફોર્સિસ લો છે. ફર્સ્ટ પોઈન્ટ આઈ થિંક યુ કેન અન્ડરસ્ટેન્ડ ઇટ કે હાઇડ્રોકાર્બન કરતાં પેરેન્ટ્સ હાઇડ્રોકાર્બનથી Rx અથવા તો કમ્પેરેબલ મોલેક્યુલર વેઇટથી Rxના બોઇલિંગ પોઈન્ટ હાયર હોવાનું કારણ એની અંદર ઇન્ટરમોલેક્યુલર એટ્રેક્શન ફોર્સીસ વધારે છે. ક્લિયર? નાવ if we can compare the boiling points of alkyl halides with different halogen, it is like that: Ri, Rbr, Rcl and Rf. If R is same, then it is a trend of boiling point, in which you can say that size of halogen atom increases or mass, molecular mass of halogen atom increases, boiling point increases. Why boiling point increases? Because size of atom increases or mass of halogen atom increases, means number of electron increases. Then boiling point increases. In state of matter, we can study that if size of atom increases or number of atom increases, then intermolecular attraction forces increases, and this three reason intermolecular attraction force increases. And intermolecular attraction forces increases, therefore boiling point increases. So remember that if R is same, then higher boiling point is of Ri, then Rbr, then Rcl and then Rf. Clear? If size increases or number of electron increases or molecular mass increases, intermolecular forces increases, therefore boiling point increases. It is like that. Clear? Suppose we can have same halogen CH3Cl, CH3CH2Cl and CH3CH2CH2Cl. If we can compare the boiling points of these compounds, then it is like that. Why? Size increases or molecular weight increases. આના કરતાં આનું molecular weight high, એના કરતાં આનું molecular weight high. Here chloride is same, chloride is same, chloride is same. If molecular weight or number of carbon atom increases, molecular weight increases and therefore boiling point increases. Clear? Suppose if we can have alkyl group is same, CH3 CH2 CH2Cl, CH3 CH2 CH2Br, CH3 CH2 CH2I, then what is the trend? Then trend is like that, because these part have same molecular mass or same size. Now chloride, then bromide increases size, then iodide increases, then the trend of boiling point is like that. Yes, if we can compare this with this, then if we can compare CH3 CH2Cl and CH3 CH2 CH2Br, then boiling point is higher in this. Clear? Number of carbon increases, boiling point increases. If halogen is same, if halogen is different, the number of then size of halogen increases, boiling point increases. It is very simple, which is given in our textbook in the form of graph. Clear? Next, the boiling point of isomeric haloalkanes. The boiling point of isomeric haloalkanes decreases with increase in branching. Increasing in branching means if we can have an isomeric alcohol, if we can have an isomeric haloalkanes, CH3 CH2 CH2 Br, whatever, it is normal. If we can have list CH3 CH CH CH3 and here bromine, it is iso. one branch is there, and we can have this CH3, CCH3, CH3, NBr. Clear? It is like that. Sorry, it is not iso, but branching is increases. Here one branch is there, here two branches there. Clear? If you can compare the boiling points of this molecule, then the boiling points decreases. If branching is increases, then intermolecular attraction force decreases. If branching increases, intermolecular attraction force decreases and boiling point decreases. Remember that. Yes. Question is asked in NEET in last year from this portion also. Clear? So it is very important. Now, clear? Branching increases, boiling point decreases. Now you can think about the boiling points of dihalobenzenes. Boiling point of dihalobenzene is nearly same. Dihalobenzene means dihalo derivatives of benzene. Suppose if we can compare the boiling point, if we can compare the boiling point of ortho, meta and para derivatives, ortho, meta and para derivatives, dichloro આપણે અત્યારે લઈએ, it is meta, it is ortho isomer, it is para isomer, it is meta isomer. Now if we can compare the boiling point, then the boiling point is in the order of ortho, para, meta. Boiling point is in the order of ortho, para and meta. Remember that. And it is near about. આના કરતાં થોડુંક જ આનું ઓછું હશે, એના કરતાં થોડુંક જ આનું ઓછું હશે. Clear? It is the trend of boiling point. Suppose now if we can compare the melting point, if we can compare the melting point of this compound, then the trend is like that. Para, then ortho and then meta. If we can compare the melting point, then para, then ortho and then meta. The reason behind this is like that. Para isomer is a very symmetrical structure. Para isomer have a very symmetrical structure which is exactly fit in the crystal lattice, which is exactly fixed in the crystal lattice to form a very strong molecule. Now if we can break it, then we can require the maximum energy. Therefore melting point of para isomer is higher. If anyone can ask why melting point of para isomer is higher, then the reason is that melting point of para isomer is higher due to its perfect symmetry. It is a symmetrical, and due to its perfect symmetry, it fits exactly in the crystal lattice or crystal structure. Therefore it is a very strong, and we can require a maximum energy to destroy it. Clear? The first point which you can remember here is like that. Now here we can complete the melting point and boiling points of haloalkanes and haloarenes. Now we can discuss about the next point, and the next point is density. The next point is density. First point is that bromo, iodo and polychloro derivatives, bromo, iodo and polychloro derivatives of hydrocarbons are heavier than water. Heavier than water. Bromo, iodo and polychloro derivative of hydrocarbons are heavier than water. Means if you can have a bromo derivative of hydrocarbon, iodo derivative of hydrocarbon, or polychloro, means more than one chloro derivatives of hydrocarbon, it is heavier than water. It is heavier than water. And the trend is like that. number of carbon atom increases, number of carbon atom increases, density increases. Number of halogen atom increases, density increases. Molecular mass of halogen atom increases, density increases. This is the 3 points which you can remember here is number of carbon atom increases, density increases, number of halogen atom increases, density increases, molecular mass or atomic mass or size of halogen atom increases, density increases. Suppose we can compare some trends. We can have C3H7Cl, C3H7Cl, C3H7Br, C3H7I, normal propyl chloride, normal propyl bromide, normal propyl iodide. You can comes up to down, then the density increases because these parts is same. Here molecular weight of halogen is increases, therefore density increases. Ana karta aa vadare dense, ana karta aa vadare dense. Clear? And suppose you can have a trend like that: CH2Cl2, CHCl3 and CCl4. Here number of halogen atom is increases. Here number of halogen atom is increases. Therefore, if we can up to down, if you can comes up to down, then the density is increases. Then the density is increases. Clear? And number of carbon atom increases, also density increases. Suppose we can have molecule like that, CH3Cl and CH3CH2Cl. If we can come up to down, then density increases. Number of carbon increases, number of halogen increases, or molecular mass of halogen increases, density increases. That is very simple. Clear? Next point which you can discuss here is solubility. Which is solubility. If we can compare the solubility, the haloalkanes are slightly soluble in water. The haloalkanes are very slightly soluble in water. Means that it is not as soluble in water. If you can dissolve the haloalkanes in the water, slightly part of this is dissolved, remaining all parts is undissolved. Why? It is like that. Clear? The reason is like that. If we can have haloalkanes and water, suppose here we can have haloalkane Rx, and here we can have a water. We know that these molecules are also attracted towards each other, and these molecules are also attracted towards each other by the hydrogen bonding. Clear? Now if we can mix these two, if we can mix these two, Rx and H2O, this is dissolved when the interactions are there between the water and Rx. કોઈપણ મોલેક્યુલ એકબીજામાં ડિઝોલ્વ ક્યારે થાય તો કે જ્યારે એકબીજાની અંદર ઇન્ટરેક્શન કરે ત્યારે. તો શું કરવું પડશે? તો કે સ્લાઇટલી સોલ્યુબલ હોવાનું કારણ કે આ એકબીજા સાથે કમ્પ્લીટલી બાઉન્ડેડ છે, આ પણ એકબીજા સાથે કમ્પ્લીટલી વાન્ડરવાલ્સ કે ડાયપોલ મોમેન્ટથી બાઉન્ડેડ છે. તો ફર્સ્ટ તો મારે એનર્જી આપી અને આના બોન્ડને ડિક્રીઝ કરવા પડશે, તોડવા પડશે. ફર્સ્ટ વી કેન ગીવ ધ એનર્જી. હવે આપણે એને એનર્જી આપશું એટલે શું થશે કે આ બોન્ડ ડિક્રીઝ થશે, मतलब કે તૂટી જશે, આ બોન્ડ બ્રેક થશે, અને એ બોન્ડ બ્રેક થશે એટલે ન્યૂ બોન્ડ ફોર્મ થશે, અને ન્યૂ બોન્ડ ફોર્મ થશે ત્યારે સોલ્યુબલ થશે. યસ, આ ન્યૂ બોન્ડ જ્યારે ફોર્મ થાય ત્યારે એનર્જી રિલીઝ થશે, પણ એનર્જી એટલી બધી હાઈ નહીં હોય કે ઓટોમેટિકલી મોલિક્યુલને ડિઝોલ્વ કરી શકે, એટલે એ સ્લાઇટલી ઓર વેરી સ્લાઇટલી સોલ્યુબલ હે. સમજો હો, પહેલાં તો આની ઇન્ટરેક્શન અને આની ઇન્ટરેક્શનને મારે બ્રેક કરવી પડે ત્યારે આની બેયની વચ્ચે નવી ઇન્ટરેક્શન થાય અને એ સોલ્યુબલ થાય. તો નવી ઇન્ટરેક્શન કરવા માટે એનર્જી આપવી પડે, પણ ફરીથી એનર્જી જે રિલીઝ થાય એ એનર્જી એટલી બધી હોતી નથી કે જેથી કરીને એ સેલ્ફ સોલ્યુબલ થઈ શકે, જેથી કરીને સ્લાઇટલી સોલ્યુબલ હે. ક્લિયર? એન્ડ નાઉ ધ સેકન્ડ સેન્ટેન્સ ઇઝ haloalkanes are readily soluble in organic solvents. Haloalkanes are readily soluble in organic solvents because હવે એનું કોઈ રીઝન નથી. જનરલી ઓર્ગેનિક સોલ્વન્ટની અંદર આપણે એને સોલ્યુબલ કરશું, ઇટ ઇઝ અ ઓર્ગેનિક સોલ્વન્ટ. આની અંદર આપણે RX ડિઝોલ્વ કરશું તો આની અને આની ઇન્ટરેક્શન બે સેમ છે. મતલબ કે એકબીજાની અંદર ઓટોમેટિકલી ઇન્ટરેક્ટેડ થઈ જશે, એકબીજાની સાથે ઓટોમેટિકલી વાન્ડરવાલ્સ કે ડાયપોલ મોમેન્ટથી બોન્ડેડ થઈ જશે, જેથી કરીને સોલ્યુબલ થશે. બરાબર? તો એક આ સેકન્ડ રીઝન યાદ રાખજો. વેરી સ્લાઇટલી સોલ્યુબલ ઇન વોટર એન્ડ રેડીલી સોલ્યુબલ ઇન ઓર્ગેનિક સોલ્વન્ટ્સ ડ્યુ ટુ ધ સેમ ઇન્ટરેક્શન્સ. અહીંયા એનર્જી રિલીઝ થશે, એટલી જ એનર્જીના બોન્ડને બ્રેક કરવા માટે રિક્વાયરમેન્ટ થતી હશે, જેથી કરીને એમાં કોઈ આપણે એક્સ્ટ્રા એનર્જી આપવી પડશે નહીં, એ ઓટોમેટિક સોલ્યુબલ થઈ જશે. ક્લિયર? ધેટ ઇઝ ધ પોઈન્ટ ઓફ સોલ્યુબિલિટી. નાવ we can think about the next point, and the next point is that now we can think about the chemical properties or chemical reactions of haloalkanes and haloarenes. Chemical properties or chemical reactions of haloalkanes and haloarenes. First of all, how many type of reaction is given by haloalkanes and haloarenes? The first point is that haloalkanes gives following types of reaction. Following types of reactions. First reaction, second reaction and third reaction. Haloalkanes generally gives three reactions. First one is nucleophilic substitution. Nucleophilic substitution reaction. Second one is elimination reaction. Elimination reaction. And third one is reaction with metal. The three reactions which are generally given by the haloalkanes, which is nucleophilic substitution reaction, second one is elimination reaction, and third one is reaction with metal. From this we can start nucleophilic substitution reaction of haloalkane. Nucleophilic substitution reaction of haloalkanes. Nucleophilic substitution reactions of haloalkane. First of all, which type of reaction is known as nucleophilic substitution reaction, and what is the product, whatever we can discuss here. First of all, what do you mean by nucleophilic? Nucleophilic means that here nucleophile is substituted. Yes or no? Nucleophile means electron rich compound. Nucleophile means electron rich compound or species. It can have an extra electron in the form of negative charge or in the form of lone pair. Clear? So here nucleophilic substitution reaction means here nucleophile is substituted or electron rich molecule or species is substituted. First of all, what is the reaction? Suppose if we can have CX here, then due to the higher electronegativity of halogen, If you can compare the electronegativity, then electronegativity of halogen is high. Therefore, it can contain partially negative charge, it can contain partially positive charge. Now, if we can substitute the nucleophile, the nucleophile is attracted towards the carbon because here a positive charge. And we can have a molecule like that. See, here nucleophile and halogen is released. That is a nucleophilic substitution reaction. That is the nucleophilic substitution reactions of haloalkane. Clear? Now, what is the nucleophile and what is the product which we can discuss here? You can understand it. કોણ એક્સચેન્જ થશે તો કે હેલોજન એક્સચેન્જ થશે કારણ કે એની આગળ નેગેટિવ ચાર્જ જ છે. એક નેગેટિવ ચાર્જ આવશે તો અહીંયાથી બીજો નેગેટિવ ચાર્જ રિલીઝ થઈ જશે. વી કેન હેવ પ્રોડક્ટ લાઈક ધેટ એન્ડ હેલોજન ઇઝ રિલીઝ એઝ X minus. Clear? So now we can change the different reagents which can give different nucleophiles and we can have different products. We can discuss some reagent for the nucleophilic substitution reactions, nucleophiles and products. Clear? Now we can discuss about some reagents, its nucleophile and substitution product and class of the product name. First reaction is that Rx nucleophile, R nucleophile and X minus. If you can use NaOH or KOH as a reagent, it gives the nucleophiles OH minus. Means here ROH. ROH means alcohol. We can get alcohol as a product. If you can use water, it is also gives OH minus. In textbook, H2O is written. And it is also ROH and is alcohol. Clear? If you can use NaOR dash as a reagent, it gives R dash O minus as a nucleophile. And we can have a product ROR dash which is ether. Next, NaI, it supplies the I minus as a nucleophile. Product is Ri. We can say that alkyl iodide is our final product. NH3, it can supply NH2 minus. Generally, it can supply NH2 minus. And we can have RNH2 primary amine. Clear? Here we can use secondary amine, then it will supply. Here hydrogen is released RNH minus. Clear? R dash NH minus generally. R dash R double dash N minus. It is secondary amine, it is tertiary amine. Yes, the point is that you can remember these two. That is very important. If you can use KCN as a reagent, it can supply cyanide ion, Cn minus. And the substituted product is cyanide or nitrile. Yes, cyanide is an ambident nucleophile. Cyanide is an ambident nucleophile. What do you mean by ambident nucleophile? The meaning of ambident nucleophile is that the nucleophile which can be attacked or attached by two sides. If you can draw the perfect structure of cyanide, first structure is like that, C triple bond N, and second structure is like that, C lone pair N minus. This is the two possible structures of cyanide. If it is attacked from this side, then we can get cyanide. And if it can attack by this side, we can get isocyanide. અહીંયાથી જો એટેચ થશે R સાથે તો cyanide product મળશે. અહીંયાથી જો એટેચ થશે તો we can get a isocyanide or isonitrile product. Clear? The nucleophile which can be attached by two sides or it can be available in two sides, it is known as ambident nucleophile. Clear? Remember that KCN is a polar molecule. And due to its polarity, it can supply cyanide. And we can get the product cyanide as a main product. But if you can use the AgCN, it is not a polar, it is covalent. It is covalent. Due to its covalent nature, it can supply this nucleophile. C, lone pair, double bond N minus. હવે કોણ એટેચ થશે N. અહીંયા આમ હતું RCN. Here R N triple bond C. It can be used or it can be written as a isocyanide. Remember that. It is due to the polar, it is due to the covalent. Same thing in KNO2 and AgNO2. Both supply same nucleophile, NO2 minus. But it can supply nitrile. It can supply nitrile like that. And it can supply nitro like that. Remember. Here are O and double bond O and here मतलब અહીંયા ઓક્સિજન એટેચ થશે આલ સાથે અહીંયા ડાયરેક્ટલી નાઇટ્રોજન એટેચ થશે. ક્લિયર? So it is a nitroalkane. Remember these two also. આના માટે આપણી ટેક્સ્ટ બુકની એક અંદર એક્ઝામ્પલ નંબર 10.5 આપ્યું છે કે હેલોઆલ્કેન્સ રિએક્ટ વિથ KCN to form alkyl cyanide as a main product while AgCN forms isocyanide as a chief product. Explain મેં તમને કરી દીધું કે it is an ambident nucleophile. If you can apply KCN then it is a polar. Due to this polarity it can supply cyanide and carbon is attacked on the nucleophilic site. It is a covalent, therefore it is weak, therefore it is, nitrogen is attached to the carbon, therefore isonitrile is obtained. Next, R-COOAG, R-COO minus, product is R-COOR, ester. If you can use LiAlS4, it can supply H minus, which is RH, hydrocarbon. If we can have R-M plus, R- is the nucleophile, RR- is the product and alkane we can obtain. So you can remember this table. In exams, MCQ is asked in the form of reagents or nucleophile or final product. ક્લિયર? મતલબ કે રિએજન્ટ આપી દીધો હોય એમાંથી કયો ન્યુક્લિયોફાઇલ નીકળશે અને કયું પ્રોડક્ટ મળશે આપણે રિમેમ્બર કરવું પડશે. એવા બે ન્યુક્લિયોફાઇલ અત્યારે આપણને મળ્યા કે જે એમ્બિડેન્ટ છે, કયા? એક સાયનાઇડ અને એક નાઇટ્રો. આ અહીંયાથી પણ એટેક કરી શકે અને અહીંયાથી પણ એટેક કરી શકે. ક્લિયર? અહીંયાથી એટેક કરે તો નાઇટ્રેટ, અહીંયાથી એટેક કરશે તો નાઇટ્રો. ક્લિયર? એક આ વાત યાદ રાખજો. નાવ in next lecture we can discuss about the mechanism. Now in next lecture we can discuss about the mechanism of these nucleophilic substitution reactions. These nucleophilic substitution reactions follows the two types of mechanism, SN1 and SN2. SN1 and SN2. So from the next lecture we can start the mechanism of nucleophilic substitution reaction SN1 and SN2. આજે આપણે આટલું કમ્પ્લીટ કર્યું physical properties of haloalkanes and haloarene, in which we can discuss about the color, state, melting point, boiling point, solubility, density. Then after we can discuss about the reactions of haloalkanes, which is of the three types: nucleophilic substitution, elimination and reaction with metal. From this we can start first nucleophilic substitution reaction. What is the nucleophilic substitution reaction? In this reaction we can apply the one nucleophile which is electron rich species and is attacked to Rx. અને RX માં એ કોની ઉપર એટેક કરશે? કાર્બન ઉપર, R ઉપર, because it is a partially positively charged and halogen is removed. If we can use different types of reagent, we can have a different types of nucleophile and we can have a different types of product like that. Clear? So from the next lecture we can start the reaction mechanisms of nucleophilic substitution reaction, which is of the two type, SN1 and SN2. So it is the main lecture. Next lecture is a main lecture because from the SN1 and SN2 so many times question is asked in the competitive exams like NEET and G. Clear? So આજના માટે આટલું મિત્રો, વધારે next time practice કરતા રહેજો.